All right there, class. We're here to do example number 2 from our vectors notes. And this example is specifically to be solved using graphical methods only. We will deal with the more mathematical methods at a later time. But for right now, we're really more concerned about the concepts that go together when we add vectors together. So let me go ahead and scroll down over here. Our goal here is to add these two vectors together and to get our resultant vector. So when we do this with graphical methods, basically the most important thing here is that we have a scale that works. So let me go over to my axes here. We're going to zoom out a little bit, and let me bring this into the middle. Basically, what I'm going to do is I'm going to use my ruler here, and the scale that I'm going to use is every 4 divisions on my ruler is going to equal 1 kilometer. So 4 of these divisions equals 1 kilometer, so 8 of them would equal 2 kilometers, and so forth and so on. All right, so my first vector here is 3.5 kilometers at 35 degrees north of east. So north of east is going to be in this general direction. So I'm going to need to bring my ruler around here, which also acts as a protractor. And I'm going to need to go 35 degrees north of that. So let's just keep going till we get to 35. 35 is right there. Okay, so we're going 3.5 kilometers. So again, based on my scale, this will be 1 kilometer, 2 kilometers, 3 kilometers, so there's 3.5 right there. So let's finish the vector by putting an arrow on it, and this is a displacement vector, so that's the vector A. Next, we have the vector B. That's going to be 5 kilometers southwest. Now, southwest is a very specific direction. Southwest is exactly at 45 degrees. So what I'm going to do is I'm going to move this till it's exactly halfway between the south and the west, and that, of course, would be this 45-degree angle. And I'm going to bring that up here, and what we're going to do is let's get an orange marker, and we're going to go 5 kilometers. So 5 kilometers, here we go. There's 1, there's 2, there's 3, there's 4, and there's 5 kilometers. Let me double check. There's 1, there's 2, there's 3, there's 4, and there's 5. Okay, so there's our 5 kilometers southwest. So let me finish the vector. Let's see here again, try that again. And it's a displacement vector, so that's the vector B. Now recall that when we do a vector addition, what I'm doing here is representing this as a tip-to-tail method, which is where I put the tip of the first vector to the tail of the second vector. And the resultant is always drawn from the origin, or from where I started, to the end. So I like to use red for resultant, and I'm going to bring up my ruler again here. And what I need to do is match this up with the beginning and the end. Let's get that in there. Let's go 1 or 2 more degrees. Let's go... it's about right there. Let's see, does that do? Yeah, I think that does a pretty good job. So we're going to go right in here for my resultant. And oh, it likes to change that to a triangle. It thinks I want them connected. I don't. And that is the resultant vector. It's pointing in this general direction here. All right. So to get a vector, we need both its magnitude and direction. So let me just move this here, and I see that this looks like 1 kilometer. I'm going to go with about 1.5 kilometers for its magnitude. So over here, I'm going to get rid of my ruler. We're going to do 1.5 kilometers, and it's at, let me bring my ruler back up so I can use it as a protractor. This 66 degrees is going to be with respect to the west. So that's going to be 66 degrees to the south of west. So 66 degrees to the south of west. All right, so I want to also express this in the degrees to the west of south, And I want to express this also in terms of what we call bearing, which is relative to the north. So I'm going to pause the video. I'm going to do that. You can do the same as well. And you figure out what they are and pick up with me on the other side. All right, while I had my video paused, I actually figured out these two other things here. And basically, if we go west of south, that is the complement, okay? So west of south would be this angle in here, and the 66 was the angle in here. So this would just be the complement of the 66, which is how we get the 24. And then bearing 204 is a measurement, an absolute measurement of value from the north axis. This would be like if we used a compass. And again, if you're not sure about this, I do have another video that can help you through this thought process of understanding that. But as far as we're concerned, using graphical methods to add these two vectors together, I'm going to get the, one of these answers would be a respectful answer for this particular question.